Hello and welcome back to our next maths lesson. And today we are going to continue looking at fractions and ordering fractions that are greater than 1. So here's our first one. If you want to have a look at what you can do with these 4 questions, pause now and have a go for me. Okay, so the first thing we're thinking about is use of equivalent fractions. So what have we done to 6 to get to 36? We've times by 6. So we have to times the top by 6 as well. So 11 times 6 is 66. Then we're comparing here one fraction with another. Doesn't matter at the moment about the top two, but what we can see is a relationship between 20 and 10. 20 is 2 times 10. So if we times this by 2, we can find out that it's the same as 50 20ths. Then we compare the 50 to the 29, and we can say it's very much bigger. Then we've got some amount of 11s is greater than 2. So what we're thinking about here is how many 11s would make 2, first off. So we need 11 11s and 11 11s. So that's 22 in total. So any number bigger than 22 will work in there. So 24, 23, any number above that would work. And then we're comparing this fraction with this fraction. 4 and 16 don't go easily into each other, but 8 does go into 16. It's timesing it by 2. So 8 times 2 is 16, times the bottom by 2 is 12. And then we compare the denominators, and we want the bigger one is the smaller one. So in this case, 16 12s. The bigger one is 12. The smaller one is 12, so that's bigger. Okay. When all of these are the rules that we've thought about before. How much we've got on top, changing from mixed numbers to fractions, thinking about equivalent fractions and what we do to one side, we have to do to the other in order to keep our number the same. Same up here, equivalent fractions, and then comparing fractions, looking at either the denominator as our guide or looking at the numerator, denominator being a guide or numerator being our guide. Okay, so all of these fractions in ascending order. So that means going up from the smallest to the largest. And what you'll notice is that none of these really go very easily together. 3 does go into 9, but 2 doesn't go into 9, and none of them go into 17. So we can't use that one. So now what we can aim for is the numerators being the same. And then we can compare the denominators and put them in reverse order in the denominators, the smallest one being the largest and the largest one being the smallest. So how do we do that? So in this case, what have we done to 2 to get to 20? Well, we times by 10, so we get 20 30ths. 4 to 20 is timesing by 5, so we times both the top and the bottom by 5. Then 5 times 4, do the same to both. And then we leave 20 as it is. And then we can order them. So we're looking at the greater the denominator, the smaller the fraction. So which one of these has the biggest denominator? That's 45. So 45 will go in here. So 4/9. Then after that, the next one, we've got 17, 8, and 30. The next one would be 30. So we can put 2/3 in here, and that uses that one. Then we've got 8 and 17. Well, the smallest one is 8, so 8 is going to be the largest, so 17 is going to go in there, and 5 halves will go in there, or 28ths. And you can just see, if you're not looking at this, if you're looking at the bottom, that was 20 45ths, that was 20 30ths, this was 20 17ths, and this was 28ths. And you can see, looking at the denominators here, smallest one is the biggest one is the smallest. So you're doing it in reverse order. Okay, have a go at this one. Order these fractions in descending order. So the numerators are the same, the greater the denominator. That gives you a hint of what you've got to do. But you're bringing descending order, going from the largest down to the smallest. Have a think. Okay, so first thing we have to do is try and get a same number along the denominator. So 60 32s we could work with, but we could go up to 60, or we could bring 60 down to 30, and that means the rest of our numbers aren't as big. So 60 divided by 2 is 30 sixteenths. Now don't worry too much if you didn't do this, you would still get exactly the same answers if you did it up to 60. The order would still be the same. It's just a slightly more complicated maths. This way it's the easiest way, because we divide the 30 by 60. That means we don't have to aim for as big a number, and we don't have to times 19 by 2, for example. So we've got that in terms, or we got 30 on the top there, 30 on the top here. This one we need to times by 30. We would have had to times by 60. And this one we can times by 6. Then we've got 30 on the top here. Now we're looking at the denominators, and we've got 24, 60, 19, and 16. And we can use that in the reverse order in order to order them. But it says descending order, so going from the largest down. So the largest one here is actually this one, the 16 on the bottom. So that goes in the first one, because this is the smallest. We're descending order, going the opposite way. So the smallest would be the largest in this case. And then we've got 19, then 24 or 60. 24 is the next one. So we've got 5 fourths in there, 5 quarters. Then we've got the last one, which is a half. And you're going from the largest down to the smallest. The important thing here to remember is what it says up here, what order you're going in. Descending is down, so from big to small. Ascending equals up. So you're going from small to big. And it's just the ones you have to remember. So order these fractions in ascending order, so going up again. When the denominators are the same, the greater the numerator, the greater fraction. Gives us a hint of what we're looking at. We're looking at trying to make the denominator the same. So which one of these, the denominators, we've got 3, 12, 5, and 6. What's our common denominator going to be? Well, we've got 3 and 12 and they go together. So we can get 16 twelfths and 19 twelfths. And we can put this in terms of that as well, 20 twelfths. Now 5 elevenths doesn't quite work in the same way because we can't put it in terms of twelfths. But 10 is double 5, which we know. Sorry, I'm just going to move this out of the way. So 10 fifths is equal to 2. Yeah, so 11 fifths is going to equal to 2 and 1/5. What we can also know is that we've got 2. Is this bigger than 2? Is this bigger than 2? Or is this bigger than 2? And in this case, none of them are. Okay, so 4 thirds, would be 1 and 1/3. 12 ninths would be 1 and 7 twelfths. And then 10/6 would be 1 and 4/6. None of them go above 2. So the first thing we can do is say that actually this 11 fifths we know is going to be the biggest one here. So we could already put that in there if we needed to. So I'm just going to make a note. This one, 11 fifths, should fit in here because it should be the biggest. Then we only have to look at the last 3. We've got them in terms of 12s, so we're just looking at the numerators. Oh, sorry, not that one, this one here. So which one's the smallest? Well, 16 is the smallest, which is 4 thirds. You see they've already done that bigger one straight in there. which is exactly right. Then it's out of 19 and 20, 19. Then the 20/12, which is same as 10/6. And that's your order. And that's just because we know that this one here, we can think about in this terms here, knowing that it is big. And sometimes what you'll see is, and they'll ask questions similar to this sometimes, and they'll have one that doesn't work. But that means there's always some way that you can relate this either to another one to find out its place, or that it's either definitely the smallest or definitely the largest, and that gives your boundaries as well. So have a think about this one. Order these fractions in ascending order. When the denominator is the same, the greater the numerator, the greater the fraction. Gives you a hint at what you're looking for. The denominators being the same. Have a look, see what you can do. Pause now. Okay, so what common denominator are we going to look at? Well, all of these fit into 40ths. So we can times 7/5 by 8 to get 56/40ths. And we can times 25/20ths by 2 to get 50/40ths. But then we've got this odd one out again, which is the 10/11ths. So what we're going to do with this one, well, this we can change to being, it is a proper fraction. All of the rest of them, look, numerators are larger than their denominators. Like I said before, remember, they normally either give it to you as the smallest or the largest. In this case, it's the smallest because it's the only one that is smaller than 1. You've got 7/5, which is improper, 44/40, which is improper, and 25/20, which is improper. The only one that's a proper fraction, got a smaller denominator than numerator, a smaller numerator than denominator, is 10/11. So we can place that straight away. Then we just compare the numerators 44, 50, 56, and then it goes in that order. Remember, normally when they've got an outlier, a weird one, it will either be the largest or the smallest or directly in the middle. So have a look at this one. You've got 5/7, 15 something, and 15/9. How might we think about doing this one? Well, we need to first off make this into 15 along the top, because then we've got 15s along the top. This one says that this is smaller. Well, yes, it's definitely got the largest numerator of these two. So this one here actually could be any number between 9 and 21. So any number between 10 and 20, basically. Because all of the denominators are the same, they're all 15. So you're just looking at it, any number between the two would fit in here. So it could be 11, could be 10, could be 13, 14, whatever it happens to be. Any integer between 10 and 20. How about on this one? This one's slightly more tricky. So let's have a look. Well, we are thinking here in terms of 14. Think about, that's your hint. Have a go, and then we'll talk through it. Okay, so I can get this in terms of 28. This is already in terms of, this can be in terms of by timesing by 2. I'll talk through another way in a minute. But this means that it can be any, because all the denominators are the same. It can be anything between the 2, which we have here, and the 12 that we have here. It can be any between them, 3 and 11. Then we'd have to halve it. Or, look, this is halvable. Yeah, so we could divide this one by 2. That gives us 1/14. This one here, we can get to 14 by timesing by 2. So this one in the middle is any number between 2 and 5, which is the same as it says here. But this keeps it in the same fraction we've got here. These ones we can relate to it. I think this way is easier personally. Okay, because we're dividing times by 2, they're saying we have to make sure that whatever number we have in here has to be even, so it can be divided by 2. But like I said before, this can be any number between 2 and 5. So this one's an interesting one because half of 21 is 10.5. So this starts off here. This must be So it can be 10.5. So as long as it's bigger than 10.5, which is what it's saying, half of this 21 is 10.5. Yeah. So it needs to be, this number here has to be bigger than that 10.5. So that means our lowest band we can have is 11. Then we've got 18 21s here. So we can go up to 17. And we could choose any of those numbers to go in here. The reason this one's tricky is because they've given you a half, and a half doesn't go into 21. But you should be able to divide whatever this number is here by that one to get you whatever the band is at the bottom, which is 10.5. Okay, so let's have a look. Rosie and Jack each have 3 identical chew bars. Jack divides his bars into 4 equal pieces and eats 5 pieces. Rosie divides her bars into 2 equal pieces and eats 5 pieces. We've both eaten the same amount because we've both eaten 5 pieces. Why do you think Jack is not correct? Have a think, pause, you could use a diagram to help you explain it, but try and understand, why is he wrong? So let's have a look. Well, here's our bars. Let's split the first bars into 4s, and that's give us 12. And the second one split into 2s. That gives us 6 of them. Now, he eats 5, so we can cross them out. And she eats 5. That leaves him with 7 quarters left. And that leaves the girl with only half left. So there is, and remember, half is the same thing as 2 quarters, so it'd be the same thing as that. The person that has the most left is very definitely it. And you can do a comparison like this by comparing the 2 numbers, and you have to times that number by 2. Or just look at the diagram, and you can see it. So now it's your turn. Write these fractions in descending order from largest to smallest, and then find 3 possible ways to complete each of these statements, thinking carefully about it. Have a go. Okay, let's go through the answers. So first, descending order, and the key one here is 16 along the numerators. Look, so we can times this one by 2, this one by 2, this one by 4, and this one by 2. Then we can compare the denominators, and we put them in descending order, so the largest one first, and then go down from there. This one, 3, 9, 9, 6, and 9. Well, that makes our life nice and easy because all of those numbers will go into 9. So we would do that. This one here, 5, 10, 10, 1, and 20. I'd probably go with making them all into 20, or this is even. So maybe half this one here, put this one in terms of tens, and put the rest of them in terms of tens. That would be easier. This would be 21 tens, because we'll just half it. And then we only have to times this by 10 and this one by 2, and then we can compare across that way. Okay? And it's just thinking about the easy way. Any way would work. It's just trying to make our lives easier, if that makes sense. Then it says find 3 possible ways to complete your statement. So we've got 4, 4, and 8. So you could make all of these into 8ths and think about it that way. Or you could half this one down to quarters. Half of that is 4.5. So as long as this number isn't bigger than 4.5, it would be fine. So it could be anything from 2 to 4, like it said here, 2 to 4. This one down here, looking at quarters and 15ths. Well, you can know how you would think about going about this is you think about this in terms of 15ths. So a quarter, 15 divided by 2, and then divided by 2 again, and you'll find that it's actually between 4 and 6 that you can go, because 7 is your upper bound, and divided by 2 is 7.5, and then divided by 2 again is 3.75, so less than 4. That's the way I would do it. You might think of a different way to do it, which is fine. And then this final one here, you've got 8, 5, 8, and 4. Well, that's not easy, but 4, 8, and 8 is. We can just then change this one, times it by 2 to get 8 over 10. Then we got 10 and 4. So any numbers between 10 and 4 on the bottom here would work. So you've got lots of choices there. Try this one for me, please. Alex and Dora each have 2 identical cakes. Alex cuts each of her cakes into 6 equal pieces and gives 10 of her friends a piece each. Dora cuts each of her cakes into 12 equal pieces and gives 18 of her friends a piece of cake each. Who has more cake left? So what you're then thinking about is how many they've given away and comparing them across how much they've got left and that sort of thing. So 6 pieces to think that through. Then the second one says, the greater the numerator, the greater the fraction. Give at least 3 examples where the statement is not true. Have a think about it. Pause now. Have a go. Okay, so let's have a look. So they've said Dora, but let's have a look. 6 equal pieces done. She gives 10 of them away. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. She has 2 pieces left. So 2 6 left. And she's done 12 equal pieces, given away 18. Say that's 12 for 1 cake gone. 13, 14, 15, 16, 17, 18. Dora has all of these ones left, which is 1, 2, 3, 4, 5, 6 12ths left. So you then can compare the 2 times this 1 by 2, and you get 4 12ths. Then you can compare the 4 12ths and 6 12ths. So Dora has the most because she's got the most here. Or you can see that this here is a third and this is a half, and you can compare them across that way as well. And there's lots of different ways you can think about this one. When the numerator being greater, so 3/17 is less than a half, which is 1. And you could have another example of 4/100ths and 1/2. Very different, because you do have to take into account what the numerator is and how many pieces you've got of that. So this is definitely not always true. Okay, thank you for that. We will see you in the next lesson. Good luck. Don't worry if you struggle with the last 2, and try to focus on those first 2. I'll see you in the next video. Goodbye.